Okay, so here we are for our fourth evening of Tips and Tricks, and we're very fortunate to have Max here, one of our star course assistants, and so
I've just put together a brief list of really useful information for this lab, and we'll start at the start. So as you know, one of the most important things to do whenever you start a lab is you got to run your pop cell. Right here we have numpy, we have EDS, which is really important. I forgot this one and it didn't make anything work. But if we have this, you're going to have one and be sure to run it. So boom. Second, we have COVID data, and right here we're just basically pulling data from a current table, and right here is your line, COVID equals read table, COVID data. So the first thing that I want to talk about is the opposite of true is false. And here's what I mean by that. So we've currently used descending equals true, which is really useful, but also descending equals false does the exact opposite. So right here, as example, we have descending equals false, and therefore it'll rank the smallest numbers first, or for here, it'll start with the earliest dates possible. Down here, we have descending equals true, just for reference to what you might have done in the past. And we are sorting by cases, and as you can see, the cases, we start with large numbers, and they descend true. So, and here's the same code pretty much, except instead of descending equals true, we did descending equals false, and obviously we see, the smallest numbers. Apparently there's negative cases. Cool. Next, I was looking at how we can sort a table to look for specific things. For example, here we're sorting this table to look for a date. So COVID, table name, dot where. So we're looking for a specific circumstance. In the column date, we want it to contain 2021. And at the same time, we're going to just run dot where again. So the date contains 2021 and 01. So only dates here from 2021 that contain 01 are going to be presented. So just know that you can actually chain together dot where to sort a table even more specifically if you're looking for something, in particular. This will come in frequent use later on when you do Lab 5 and the Olympic mini project, which will be coming up kind of soon. Next, we have a table. It's Nobel, and I think it's just loading the American Nobel Peace Prizes that we've attained from chemistry, biology, and just overall count. I don't know what this specifically one is, small numbers, but whatever. So we can sort for a year. Like for example, right here, we did eds.filter tdate Nobel, and we're sorting it between a specific time. So eds is kind of like when we use numpy and we use np dot. So we have our own set of commands, and one of the most useful ones is filter tdate. And the reason why we have this one is because basically all clocks start counting from the same point in time, which is a very, 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 very long time ago. And the worst part is it's counted in seconds. So in order to make life a lot easier, the staff up, that do all the big coding have come up with eds.filtertdate, and it will let you enter something like Noble, like the name of the table, and then it'll give you two dates, which will be sorted here, and it will sort dates out for you. So for example, what I could do is I could do oh, by the way, eds.ptrend is another one where you can actually plot things a lot easier in a graph like this, but we can use this command on Noble filter, so filtered set of dates, and then we can still filter by week and then by biology, which is right here. And then FMT date just makes everything else run easy, and it'll produce a graph like this. There's going to be a problem very similar when you do your lab 4, and just note that you can filter dates and then run a trend line on them. And that is a very smart way of just look at this, like January 2020 to 2021. Next, we have histograms. Histograms kind of look like this. Unfortunately, I couldn't really pull a good example, but this is the one I got. Um, and note that histograms and trend lines are different, and some are better for plotting different things, and you'll see them come up very frequently throughout this class. So right here, I just have early 2022. So for example, let's just say we're looking at COVID. And oh, this is late actually. Oops.
That's okay. Yeah.
So we have late 2022, and basically what we're doing is, as we used earlier, eds.filter to date, COVID, the name of the table, or the command that runs the table. And then we have a set of dates. And by doing this, huh,
Hmm. Oh, the COVID data may not. Yeah, there you go.
okay. There we go. So we can filter by specific date. So here we're going to look at COVID from late 2022. Obviously, this is not correct. And then we just filtered it. So if we look at the dates by which these occur, like look at that, like it starts counting at November and it's going to end at December 31st. So by doing that, we can basically just pare down a specific section or a specific set of times within a table and look at those. So right here, for example, what I did was I just plotted the date. The date, these numbers are basically the correction that we've made through EDS, or so the EDS command. And then we can plot something like cases per 100,000, and it'll give us a graph like this. Um, I hate to say I have a very brief presentation. That's all I had, but hope that helps.
That's super, Max. Super. Yeah. Wanted to point to one or two things which were great that you pointed out. Maybe in the early going, I know even in lab 3, uh, some people are having trouble with the code, for instance, the table read table. Um, inside the read table there is this string variable which contains a the way in which we're going to get the file which we're going to work with in that table. So that COVID data there is again that important string variable. So I think I noticed in lab 3 a number of people had trouble when it was loading. People were loading epi.yale.csv, that file. They had to use the same read table approach and had trouble there. So this is a parallel. So it keeps coming. So those who kind of learn as much as they can from lab 3 should find this lab possibly a little bit more straightforward. So that I hope that that's helpful to people as well, pointing that out. But we couldn't do so without Max's good good presentation here. So super, super. Uh, yeah. So Max having served both as a course assistant, but also taking the course. Um, what would you say? Let's say lab 3 versus lab 4. What do you remember finding most difficult for students or for yourself?
So I thought that lab 3 was a little bit more straightforward.
Mm-hmm.
And the big thing that I did stress is the EDS commands. Like for example, eds.filter to date, eds.ptrend. Those are really, really useful. And the biggest thing that I will tell you guys honestly is that GPT will not help you with this one. Because we have our own set of commands. As I mentioned earlier, time is counted by all computers the same way. It's from a set point in time a long time ago, and it's counted in seconds. And when I did the class, the EDS commands never existed, and so I got very, very, very sloppy looking charts because the timeline was off. Your x-axis was just broken in a sense. And so it's just really important to make sure that you're keeping on track of the x-axis on most graphs. That's what screws over a lot of people.
Yeah.
And also I would say that it's really easy to filter, like, when you did like the Eastern markets, like it's really simple to just knock out certain columns. And that is a really, really good tool to take into Lab 4. If you can isolate a table like COVID data and take out columns that you don't need, you can focus a lot more on the few columns that you do. And that helped me really work through Lab 4 instead of just seeing a whole large jumble of numbers in a table that was way too big to read.
Well, those are great tips. Very, very good. Very helpful there. So, so excellent. I had one or two things that I might share because I know that there are a few listening who are sort of at this turning point, trying to finish Lab 3, but also have an open mind toward Lab 4. So wanted to share one or two things that I had shared in a little bit different form in the classroom. But I think each time we see it, that could be useful as well. And then if you have some comments, Max, with some of the things that I show, it'll be very brief, and then we can go to Q&A for these fine people waiting with us. So great, great. Okay, so I'll try to share. Yeah, I think I see it here. Okay. So here, I labeled this Lab 3 tables. It's not really just Lab 3, but I just want to make sure and reinforce what we've learned so far with the tables, because again, as we get to Lab 4, which Max has really nicely introduced, we want to be more and more kind of efficient and empowered in our work with data and data tables. So here, like Max had shown, we need to import certain things to work with tables. Now for you, within the labs, Lab 3 and Lab 4, there is a cell, initialization cell at the top. So you won't, at least at first, until you get toward later on working with the mini projects and the group projects, you won't need to initiate these commands yourself. So we know by the one that this has gone forward. Here I'm actually going to clear the output just so we can see it a little bit cleaner. So again, I'm running this again. Now I'm assembling a table here so that we can do some of the manipulation. So here what we have is using the with columns, okay? So again, to construct a table, we have two ways. One is the with columns, and the other is a read table. Lab 4 focuses almost exclusively on using read table to bring the data sets in, particularly the COVID data. Lab 3 uses a mixture of means. So here's our very, very simple table. Now, one thing that's noted, like if you're paying super duper attention here to this table and trying to kind of take this exactly and use it in Lab 3, the thing is that there are some slight differences in the names and so forth, and those differences matter. So when you're reading the questions that are presented, like in Lab 3 or 4, you want to read them very carefully, because the details of what's asked, of course, is important. And smaller things, like what you will label the columns with, are also important to keep track of, because oftentimes as you're working through it, you may have perfect code, but the check will come back and say, that's not the right table, or that's not the right information, because you haven't appropriately labeled these columns. So just pay mind to that, because here I've purposely used slightly different labels than those that are in Lab 3. So then once we have this small table, we would like to add to this another potential flower. Here I call it templeweed. So we'll add that. Now, here, first off, I have developed a list, and then the list, I have added a row, not using with columns because a row is not a column. I use with row, and it's singular because I'm only adding one row. Okay, so that is important. My list is indeed a list, as exemplified by the square brackets. So now we have this. So now, one thing is, we might, in many labs, Lab 3 and then into Lab 4, we might want to extract this column. So the very important command that we're going to use quite a bit is the dot column. Dot column will extract the array. In this case, it will extract the array with this label, petals. So here we can see 4, 7, and 33 came off, which is exactly the numbers here. Okay. Now, question might be, for instance, you might see question in the lab, or you might want to know because of the when you're getting more toward the mini projects or other aspects, you have something you're studying. You would like to understand the average of the values in a given column. So first off, we need to convert this to an array, because then once we have an array or even a list, we can take the average of that. We can use a wide range of NumPy different approaches. Mean and average have the same meaning, but there are others like median. In this case, the median is one and the same with the average. But if we have a different set of numbers, we can see the median is somewhat different. In this case, I think I've come up with a good example here, and the median's a little bit lower. So the question is, if we want the average of this column, we have to pull out the column, which is this first part here. Okay, so let's zoom in. Here's the column, petals. And now this object can go inside. See where the green highlighting is? This is NP average. NP average, just like up here, now this is mean. I could change it to mean, that's fine too. Is a function. It's a function within NP. You need to put in the green parentheses is where the argument goes, which in this case, it's an array. This is an array. So now when I run this, I get a value, 14.66. Then just for what we call a sanity check, you should look back at the table. And when you look back at the table, you say, okay, I have one number 33, another 7 and 4. Makes sense that the average is 14.6 here. It wouldn't make sense if the average was larger than 33 or less than 4. So it's always good to check. Why check? Well, the numpy.mean is not going to make a mistake, but if you did something along the way that altered the numbers, or you were grabbing other numbers than you thought you were, then that's the reason why it might be different. So the column is very important, because here, if I do this, I get an error. It's a big error, okay? But the reason I get a big error is because my 3 flowers is this table. okay? You cannot take the mean of my 3 flowers. It wouldn't make any sense because the table has labels in it. It has text labels as well in this column, or names, and then it has petals, which could be averaged. So you need to extract the data from the columns like this. So that's why we have to put dot column, and we have to be specific with that. And we have to be very careful. We can't put capital P petals, or something I've seen very frequently. Working fast, someone's like, oh, it's petal, okay? You do this, it says petal is not in the table. The table contains these two. Oh, here's the one, petals, okay? So there's your petals. Now we get the mean, okay? Two last parts I want to show you. One is, how can we get the name of the flower with the most petals? So this question is like getting the country of the largest decade change in epi, okay? So here my 3 flowers dot sort, okay? Petals descending equals true, okay? So this is what Max was talking about. Here's true, here's false, okay? So now with false, we do get the lower one here. It is also possible to sort by name, but in that case, you're sorting alphabetically. So descending equals false means that you're going from A to Z, basically. But what we're interested in is the petals, okay? And then the question is, how can we get the top one? So we want to bring it to the top. Tumbleweed has 33 petals, so that's the one we'd like to get. So first off, we need to sort it, and then let's remove this part for right now. We need to get the column. So the column has exactly these labels, and we know this is the one we really want. So we don't just type it somewhere because we know it's the one we want. We can use dot item 0, okay? And we get tumbleweed, okay? If we want to set this equal to a variable, we can do exactly the same thing and go here, okay? So that's the plan there. Now, one further thing that we might want to do with a table. So let's create a different table here, and this table is going to have the years from 1980 to 2000. So how will I do this? I would say table, and then with columns, okay? And then with those columns, what I would like to do is give a label for 1 year, and then I need to put an array, because the way with columns work is you give a label, which is a string, and then you need to give an array. So here, if I want the years from 1980 to 2000, then I'll have to put 2001, and I can put a step of 1. So now I have my table, okay? So there's our years, okay? What I would like to do is identify those years that are odd, okay? Not strange, like 1987, that's a strange year. No, odd meaning 1981, 83, 85, etc. So how can we do that? Well, let's take 1987, for instance. And then if we use, if we use this, we get that, okay? What this is what's called the modulo. means the remainder from the division. So if we go to 86 here, we get 0. So even years, we're going to get a 0. Odd years, we're going to get a 1. So now what I would like to do is add additional columns to my table. So my table dot with columns. Now I would like to call this odd. And then what I would like to do, by combining a few steps, I can take my table dot column, and then here it's quote year, okay? So that's an array. That array I can do times 2. I mean, it's not times, it's modulo 2. So if I do that and look at the result, we see this outcome. So here we could call this my odd table. I'm almost done here, and then can address further question and answer. So my odd table, we can look at it, but now I'd like to limit. So the question might be, limit the table to just the odd years, okay? So limiting to those years, what we would do is say my odd table, oops, that's strange, my odd table, okay, which is a table where now we have to tell it which column. And then here we can either say r equal to r dot equal equal 2, and then in parentheses we can say 1, for instance, okay? So now what we would get with my odd table is you're only getting the odd years, okay? As an alternative to this, when you're doing equal to, you can simply put the number there and we get the same result, okay? Now, presumably there's other data in the table. This table only has the years. In other cases, this might be, for instance, the IMDb ratings, and then you would have simply 1 year, okay? In here, it is possible. So for instance, we could do this computation outside, create an array, and put it in this position, but this always has to be an array. This is an array because I use the dot column year times %2. And I'll just show it, and then we'll be right for further questions. You can see it's an array, okay? So that's why here, when we're doing with columns, we can put an array here. It's just we did a further computation here. So that's what I wanted to share there. So great. So we'll stop the share and